Welcome back to our Math 171 video series. For this set of videos, we'll be dealing with inverse functions and how to write them and finding their domains and ranges. Our first problem gives us the function y equals x minus 4 squared plus 5, and it specifies that the domain is 4 to infinity. Our job is to find the inverse of the function and then find its domain and range. We'll start with finding the inverse function, and our first step will be to swap x with y and rewrite the function. So where y is, we're going to say x instead, and where x is, we're going to say y instead. The rest of the function will not change. Next, we're going to try to get y by itself. If our goal is to get y by itself, we're going to have to first move the plus 5 that's on the outside. We'll now say minus 5 on both sides. If we do so, the left will now be x minus 5, and the right will be y minus 4 to the second power. Now we're going to have to remove that second power, and the opposite of second power is the square root. We'll take a square root on both sides, and that square root and the second power will cancel out. The reason why is because the square root and the square are inverse functions. Any function that is operated on its own inverse cancels it out completely and only leaves behind whatever is inside both of them. And any time that you have a second power, you can always use a square root to remove that second power, because they are inverse functions. Now, it turns out that the function we started off with also has an inverse, and we'll find it by the end of this problem. As for the square root, it will cancel out with the second power. I'll cross those out in orange, and that will leave behind only what is inside the parentheses, and that's y minus 4. Inside the root on the left, we'll have x minus 5. Now we've almost gotten y by itself. All we need to do now is to move that minus 4 by adding 4 to both sides. If we do add 4 to both sides, we will end up with y equals square root of x minus 5, and then plus 4 on the outside. This will be our inverse. With this in mind, we will now find the domain and range of the function and its inverse. On this new slide, I've written our original function and our inverse function, which I've labeled with f-1x. That abbreviation stands for inverse of the original function. In this particular problem, we've already been given the domain of the original function. That's 4 to infinity. Now, interestingly, the domain of the original function becomes the range of the inverse function. Since domain measures x and range measures y, and we swapped x with y to get the inverse, it naturally follows that the domain would become the range because x has become y. So we will write that our domain for the original fx was 4 to infinity because that was given to us. And now we can write that the range of the inverse will also be 4 to infinity. Now, notice that we do not know the range for the original function, and we haven't yet gotten the domain for the inverse. But since the domain of the original has become the range for the inverse, we can also say the domain of the inverse becomes the range of the original. So this means we need to find the domain of our new inverse function. But remember that since we do have a square root inside of our inverse function, we know that that must be greater than or equal to 0 according to our domain rules. So we'll say x minus 5 is greater than or equal to 0. If we add 5 to both sides, we will get x is greater than or equal to 5. We will quickly draw a number line here and note that greater than or equal to means we're looking for a closed dot, and we will go right on the number line. Now, place the infinities on the left and the right, place our closed dot at 5, and we will shade toward the right. We can see that our domain on the number line starts at 5 and goes to infinity. That's what we'll write for our domain. But since the domain of the inverse becomes the range of the original, we can also say that the range is from 5 to infinity. And so this is how we find the domain and range and inverse of a quadratic function.